Lesson 3. Frames for FPV drones. Every FPV drone assembly begins with the selection of a frame on which all necessary components will be mounted. It consists of a body and arms. The body consists of two plates, an upper and a lower one. All the drone's electronics are mounted on the lower plate, while the motors are placed on the arms. The quality and thickness of the arms are crucial for the drone's durability after crashes and for minimizing vibrations from the motors, which can affect the drone's performance. The size of the frame will determine the style of flight and the flight characteristics of the drone itself. You can assemble a racing FPV drone, a drone for video recording, or a drone designed for long flights. There are complex frames for those who prioritize mobility. The frame not only consists of our components but also defines the aerodynamic properties and overall strength of the entire drone structure. Therefore, it is essential to choose it with the right approach and for specific tasks. Here are some factors to consider when choosing a frame for your FPV drone. Its size and the tasks you set for yourself. The shape of the frame. The construction of the frame. The material it is made from. The size of the central mounting scheme for the electronic components that will be used and the sizes of the motor mounts. Now let's discuss these aspects in more detail. Drones are often referred to as 3 inches, 5 inches, or 7 inches, etc. For example, a 7-inch frame accommodates a 7-inch propeller. 1 inch equals 2.54 centimeters. If 2.54 times 7 is equal to 17.7 centimeters, this means that a 7-inch frame can accommodate a propeller no larger than 17.7 centimeters in diameter. You can even take any frame and a ruler to measure in centimeters the straight line from the center of the motor to the nearest point of contact with the frame. However, it is essential to measure both the front and rear arms because frames can have a trapezoidal shape, where the rear arms are closer to the body than the front ones, and we select the propeller based on the smallest distance to the body. Different sizes of propellers are not installed on the drone. For example, take the frame and first measure the distance from the rear arm from the center of the motor shaft to the frame. If it measures 10.6 centimeters but is very close to the frame, we reduce the size by approximately 5 millimeters to 10.1 centimeters to ensure the propeller does not hit the frame. Next, we measure the distance from the front arm from the center of the motor shaft to the frame, which comes out to 11.5 centimeters. This means the front arms have a greater distance to the frame than the rear ones, so we will choose the propeller size based on the rear arms. Thus, we have a size of 10.1 centimeters for the rear arms. Now it is essential to check the distance between the front and rear arms from the motor shaft to the motor shaft on one side, as it may happen that the propellers will hit each other. If this distance is 20 centimeters, it means that our 10.1 centimeters propeller will not fit here, so the maximum size we can install is no more than 9.52 centimeters to avoid them hitting each other. The obtained radius of 9.52 centimeters needs to be multiplied by 2 to get the diameter of the propeller. A propeller with a diameter of 19.05 centimeters is the maximum that can be installed on this frame. Now we convert this value to inches. The diameter of the 19.05 centimeters propeller is divided by 2.54, resulting in 7.5 inches. This means that this drone is 7.5 inches, and we can install a propeller specifically for 7.5 inches. With this calculation, we can accurately determine the frame size in the commonly accepted definition in inches and eliminate the possibility of incorrectly sized propellers for our drone. If you have already been looking for a frame for your FPV drone, you have likely noticed that frames have a range of lengths for each size defined in inches. For example, a 4-inch drone can range from 150 to 180 millimeters, a 5-inch drone from 180 to 220 millimeters, and so on. How is this measured? You take the diagonal distance between the centers of the motor shafts. This gives us an understanding of how large our FPV drone will be. This value will provide us with an understanding of the commonly accepted calculation of frame size in inches. Since frames have length ranges, accordingly, an FPV drone can be from 7 inches to 7.5 inches, as in the case of a 7-inch drone. The same applies to other sizes. Roughly speaking, a 7-inch frame with the smallest diagonal size of 295 millimeters will not be able to accommodate a 7.5-inch propeller. The propeller will physically hit the frame. Similarly, it is ineffective to install a propeller from the largest 7.5-inch size onto a precisely 7-inch frame. Now let's talk about the frame shape. True X, a classic X-shaped frame configuration. This frame has the shape of the letter X and is very common among FPV drones. It provides stable behavior during fast flight and maneuverability, ensuring balanced control. Stretch X. This frame has slightly curved arms, allowing for greater stability at high speeds and better maneuverability. Deadcat frame. With widely spaced front arms, this design helps avoid the propellers entering the camera's field of view. This frame is more common on FPV drones used for freestyle or video recording. H-frames. These are excellent for racing due to their stability and sufficient space for equipment. Box frames. Essentially a closed X-frame. It has connections between each arm and is extremely sturdy. However, the additional material creates greater resistance during flight and increases the overall weight of the drone, which affects its speed and maneuverability. Plus frames. These have a plus shape. They are used very rarely, mainly to impress with the unusual appearance of the FPV drone's frame. The drawbacks include unique aerodynamic properties that one must get used to, and the front motor with the propeller will always be in the camera's view, which can be an obstacle during the entire flight. Now let's talk about the frame construction. There can be two types of frame constructions, monolithic or made up of separate parts. Regarding the monolithic type, everything is clear. The arms and central body come as one element. However, if one of the arms breaks, it will require purchasing a new frame. A frame made up of separate parts must include 4 arms, upper and lower plates, spacers between the plates, camera mounts, and bolts. This is if we are talking about a standard FPV drone assembly. This allows for modular replacement of just the damaged part of the frame. There are also frames with reinforced arms to increase the strength of the entire structure in case of heavy loads on the frame, featuring a crossbar between the arms on both sides. What material is best to choose for your FPV drone frame? Currently, carbon fiber frames hold the top position. Carbon is one of the most expensive but also the strongest, lightest, and stiffest materials available on the market. This material is lightweight. The lighter the FPV drone, the greater speed it can achieve, better maneuverability, and increased flight time. Carbon frames are very strong and can withstand high loads and strong impacts from falls or collisions. To ensure your FPV drone can withstand the impact force from a fall from a height of over 100 meters, it is better to choose a carbon frame with arm thickness of at least 5 millimeters. However, nothing is perfect. Carbon fiber has its drawbacks that must be considered when assembling your FPV drone. Carbon fiber is electrically conductive. If you have uninsulated electronic components connected to the frame while powering them, it can cause a short circuit and burn out the component. It can also block or weaken radio frequencies, so antennas on a carbon fiber frame should be mounted on the outer part of the frame for optimal signal strength. Let's talk about the other materials used to make frames and their advantages and disadvantages. Steel. This material is one of the cheaper and stronger options. However, it is also the heaviest, which immediately limits the possibility of fast flights on an FPV drone. Aluminum, also a cheap material. Its advantage is its lightness. However, this material is prone to bending from impacts due to falls or collisions of the drone. Titanium, a lightweight and strong material, but very expensive. Textilite, a heavy, flexible frame that cannot withstand strong loads. Due to the flexibility of the material, the drone's flight performance is compromised. Pressed cardboard, a cheap material with good aerodynamics. However, it is very heavy due to the large thickness of the arms on the frame, approximately 2.5 centimeters. Wood, A cheap, heavy frame. This immediately affects the drone's flight characteristics, making it less maneuverable, heavy, and slow. Plastic or acrylic, a lightweight, cheap frame. However, it is quite fragile. A drone assembled on such a frame will completely break upon falling from a height of 5 meters. In other words, it is a one-time frame, good only until the first fall. Typically, plastic frames are printed on a 3D printer. Printing a frame larger than 5 inches on a 3D printer is challenging if it is a monolithic frame. If printed in separate parts, a 7-inch frame is the maximum size that can fit into the printer. Printing a frame will take an average of 8 to 10 hours. However, it will also fail upon the first strong impact, which cannot compete with the characteristics of a carbon frame. Thus, there are many materials from which frames are made. There is plenty to choose from according to your budget and preferences. Now let's consider the sizes of the central mounting scheme on the FPV drone frame and the mounting holes on the arms for attaching the motors. The central mounting scheme on the drone frame is a defined space for mounting the main electronic components of the FPV drone, such as the flight controller and ESC. These are holes in the central part of the lower plate of the FPV frame. Consequently, the mounting size of these two components must match the size of the central mounting scheme on the frame. These sizes are important for planning the placement of these components and ensuring enough space for all other necessary electronic components. Each frame will have its own size for the central mounting scheme, which should be checked in the frame specifications. However, there are several popular sizes made by manufacturers for frames ranging from 4 to 10 inches. These include 20 by 20 millimeters, 25.5 by 25.5 millimeters, and 30.5 by 30.5 millimeters. On many frames, this mounting size can be variable, allowing users a greater choice among electronic components that can be installed on the drone. For example, both 20 by 20 millimeters and 30.5 by 30.5 millimeters can be accommodated simultaneously. These holes are located right in the center to ensure that the center of gravity in the drone is properly distributed. Additionally, it is important for the flight controller to be located at the center of the FPV drone frame so that the accelerometer and gyroscope can process the drone's position in space more accurately in relation to the motors. The arms of the FPV drone also have mounting holes for attaching the motors. These sizes will depend on the size of the frame and the thickness of the arms. The size of the mounting holes for attaching the motors is defined by the distance between these holes. The most popular distances between holes are 16 by 16 millimeters and 19 by 19 millimeters. Such distances are used on drones starting from 4 inches. On smaller drones, the distance is 11 by 11 millimeters or 12 by 12 millimeters. The height of these holes will also depend on the thickness of the frame's arms. Therefore, in addition to weight, material, and overall and mounting sizes, when choosing a frame, it is also important to pay attention to aspects such as aesthetics, mounting of the FPV camera, mounting of additional cameras like GoPro, availability of spare parts, and motor protection. I hope you now understand that there is no perfect frame for everything. It all depends on your requirements and the intended use of the FPV drone in the future. An ideal FPV drone frame should be strong and practical while being as lightweight as possible. If you want more protection, the frame will use more material, thus becoming heavier. If you want more practicality, you will use more accessories, which will add weight. If you want to reduce weight, you will have to sacrifice both strength and functionality. We simply cannot have it all at once. You need to determine what is more important to you. With a basic understanding of frames for FPV drones and knowing which characteristics to pay attention to, you will be able to choose the necessary frame for yourself.